Hello and welcome to the third DUG Virtual Azure Snack. In this series of 4 episodes, we make you rethink your current hosting setup. Today's show is live on Microsoft Learn TV, Microsoft Twitch, as well as the DUG Virtual website. Before I introduce myself, I want to point out that we do have a code of conduct for the chat, for example, and that you can find the link to that in the chat. This series is made accessible with the help from both Microsoft and Umbraco and their commitment to accessibility. Thank you very much. I also want to bring attention to the Microsoft Azure Challenge. This challenge covers everything that we are talking about in the series. And at the end of these 4 episodes, we will pick 3 lucky winners who will receive a Microsoft gift bag. You can find the link to this challenge in the chat, but also on the virtual.dug.nl website. Welcome again to this event by the Dutch Umbraco User Group. I am Arnold Visser, one of the directors of the Dutch Umbraco User Group Foundation. We organize meetups and events around Umbraco and subjects related to the Umbraco content management system. Our Azure Snack series contains 4 episodes where we take you on a journey through the Azure landscape and dive into the components needed to run Umbraco or any other web app successfully on Azure. In this 3rd episode, we will dive into Azure networking with Microsoft Cloud Advocate Sarah Lean. And now it's my pleasure to introduce the host of this episode, Emma Burstow, Developer Advocate at Umbraco HQ. Welcome, Emma.
Hello, thank you for that lovely welcome, Arnold. Nice to see you today.
Nice to see you too.
So I'm going to introduce our guest today, who's Sarah Lean. She's a Microsoft Cloud Advocate.
Hello.
Hi, Sarah. Hey, nice to meet you.
You too. Thank you for having me today.
Oh, it's lovely to have you along. I feel like I already know you. I've been looking at your blogs and your YouTube channel. There's so much out there, actually. It's really so much content.
Awesome.
So today you're going to be speaking to us about Azure networking, but I've been learning from your blog and looking at your YouTube, and one of the things that I learned was that the unicorn is the Scottish national animal.
Yes, it is. Yes, it is. And that's why it's kind of my logo. And I don't know if you can quite see behind me. If I point the right side, there is a unicorn in those teddies up behind me as well, Emma. So yeah, it's there to represent where I come from and where I'm based from. So.
Oh, lovely. Well, at Umbraco, we love unicorns too. So much so that the headquarters office has the place that it was on, the street has been renamed to Unicorn Square. So
nice.
I didn't realise we had so much in common, but it's lovely. I think I've got a unicorn around here somewhere too. But so I'm going to hand over to you, and you'll tell us a bit about Azure Network. And at the end, there'll be a Q&A. So I'll ask any questions that any of the viewers have posed. We'll come back and we'll have a chat. And then afterwards, we'll be in the cafe, which is a Microsoft Teams meeting, which all are invited to join us. But for now, I'll stop talking and pass over to you. Thanks, Sarah.
Awesome. Thank you, Emma. So yes, thank you everybody. Today I want to talk about scaling with Azure and some of the possibilities that you have with the features and products that we have. As Emma said, I'm a senior cloud advocate here at Microsoft, and you can find me on my blog and my Twitter, techieelass.com. I'm an IT pro, so I always tackle these infrastructure projects, or any project even, from that point of view, from the infrastructure or the operations point of view. So that's where I'm going to be taking you today on the journey. And it's really about the art of the possible, because at Microsoft we have well over, I think it's like 250 services at Azure, and I'm going to take you through some of the services that we use in the networking components that can help you scale your applications and deal with the fact that nowadays you have to think about how to deliver your workloads and your applications globally, whether that be internally to your your employees, your colleagues, or if it's externally facing for your customers. Now at Microsoft, we have, like I said, lots and lots of different networking solutions, and you can think of them in 4 different pillars. So we can think about the connect part of the networking piece. We have the protect part, which looks after and tries to detect and prevent anything malicious getting through into your network. And then we also have the monitoring corner, where it looks after things and gives you that kind of information around your logs and tries to help you, be proactive and find anything that potentially has got through that protect net and help you deal with all of that. Now, today we're going to be focusing on that fourth corner, that fourth pillar, which is delivery. So we'll be talking about things like the CDN networks, load balancers, traffic managers, and we'll try to dive into what they all mean and when they're appropriate to be used. Now, first of all, I want to kind of set the bar so that we all know what load balancing is, or what a load balancer is. I'm sure we are all familiar with it, but again, like I said, I want to set the scene and make sure that we are all on the same page. A load balancer is basically something that helps you distribute that load. If you think about it from a non-technical point of view, it could be that you're moving house and you invite some friends and family round and they help you share that load of taking all your furniture, all your belongings out of the old house and into the new house. And that's really about distributing that workload, because if you were to do it yourself, it would take a lot longer. Hopefully with friends and family helping you, then you would get through the task much quicker and it'd be less stressful on you as well. And that's ultimately what a load balancer is looking to do, kind of make that load, that task in hand, much better for the end user that's using them. Now, in terms of why you want to use a load balancer from Azure and from Microsoft, there are a lot of benefits of it. One of the big benefits that you see with a lot of the networking and the load balancing technology that we have at Azure is that it has been battle tested. And by that I mean we actually use it ourselves for our first party solutions. So things like Teams or Bing or the Xbox platform all use the technologies that I'm going to be talking about today. So they have been battle tested, because with all due respect to all of your workloads, some of the workloads that I've mentioned, think about the Xbox network and the load that it takes. It definitely has to be able to deal with a lot of traffic and be able to deal with a lot of scenarios, and a global service as well. So these products that I'm talking about today have been battle tested by some of our first party customers, as we call them here at Microsoft. Now, I want to talk about the 4 options when we talk about load balancing, and those were on the slide I talked about earlier. So we have the load balancer, the application gateway, the traffic manager, and the front door. Now, some people get a bit confused when they look at these options, because they think about which one should I actually be picking, which one is best fit for my scenario. What I'm going to be doing is taking you through each of these scenarios and trying to lead you down the path of understanding which one is appropriate for you, and when you should maybe use one versus the other, or maybe when you actually look to combine 2 of them together. There's lots of options here, but hopefully this session will help you understand them. Now, the Azure Load Balancer is our networking load balancer. It operates at layer 4 if we think about the OSI model. And because it's at the closest to the networking stack, it can help us get a low latency for our applications. And for applications that are sensitive to latency, this is a great choice of feature for your load balancing. Now, it's a super lightweight load balancer. What it actually does is takes the packet from your end user and then just passes that packet on to the endpoint that the routing algorithm that you have set up actually allows it to do. So there's nothing happening to that packet. It's just getting routed to the place that it needs to go. Now, there are various different components within the Azure Load Balancer, and I want to take you through some of them just again so you're familiar with the terminology if you come across it within the Azure Portal versus the documentation. Now, the Azure Load Balancer is something that can be used publicly, so it can be internet facing, or it can be internal only, so no internet traffic hits it, it's just internal to your own networking traffic. We have the health probes, which understand whether your endpoints are healthy or not and can actually receive traffic or not receive traffic. So that's obviously a key part of the load balancer, because the last thing that you want to be doing is routing traffic to something that isn't there or isn't available for your customers. Now, one of the features that I like about the load balancer is that you can actually do an internal NAT rule or an outbound NAT rule, where all of the virtual machines that are behind your load balancer, when they access the internet, their public facing IP is actually the load balancer's IP address. So again, it's trying to minimize your operations and your management for that overhead, and obviously reduce the amount of public IP addresses that you have. Now, with a load balancer, it can support things like virtual machine scale sets, and just IP addresses at the back end. Now, the IP addresses is an interesting one because it allows you to separate the need for associating, say, a virtual machine to that load balancer. So you can always depend on that IP address being there. So you can, delete that virtual machine, and as long as that new virtual machine that you add into the backend pool has that same IP address, once that new virtual machine becomes into play, it will just become another endpoint. It's also great if you're setting it up and everybody has different jobs and functions when they're setting it up. If you haven't quite set up the virtual machines, but you know the IP addresses that it's going to be set up to, when the person that sets up that load balancer, they can again just set up the IP addresses, and as soon as the person who is in charge of creating those virtual machines or the virtual machine scale sets does that, and they become valid via the health probes, then the load balancer actually does its job. So it's a good feature to have a look at. Now, one of the things that I want to talk about is the routing and how we classify that, because when we actually look at some of our documentation, we talk about tuple hashes, and then when we actually go into the implementation in the Azure portal, we call it something different. So I want to make sure that you're aware of this. Now, there's something called the 5-tuple hash that we can do. Now, if the query from your end user matches a source IP, source port, destination IP, destination port, and protocol, then it'll always send it to that backend pool, and that's what we call the 5-tuple hash. We also have the 2-tuple hash, which is matching things like your source IP and your destination IP. And again, if those two match consistently, then it will always be sent to the backend pool, the same backend pool. And this is you configuring a kind of session persistence or a stickiness for your end users for your workload. Now, the one thing that I did notice when I was researching for this talk is that when you look into the Azure portal and you're starting to configure your load balancer, the terminology is slightly different. So when you go into the Azure portal, you'll see a setting called session persistence. And then you'll get 3 options. You'll get none, which is actually the 5-tuple hash that I explained. You'll get client IP, which is the 2-tuple hash. And then there'll be a third option, which is the client IP and protocol, which is the 3-tuple hash. And that looks at your source IP, your destination IP, and the protocol. So that's one thing to be aware of. Now on screen, you'll see a kind of example architectural diagram of using the load balancer. Now there's lots of use cases for using this load balancer, but this one represents something that you can potentially do where you have that public facing load balancer and then it services your internet requests from someone external. And this diagram's maybe not the best because it's using port 80. I'm not sure you want to expose that maybe to the internet, but it would then take that query, pass it on to the web tier, so the virtual machines that host the web app, the public-facing web app. And then at the back end, there would be another load balancer that is internal to your network. And then it would pass that traffic on to, say, the database side of your application, or as we've called it in this diagram, a business tier. So that's just an example of a configuration that you would use with your Azure load balancer. But like I said, there's tons of other scenarios that you can go through with it as well. Now, the second load balancer that I want to talk about is actually our application gateway. Now, this is more suited for HTTP or HTTPS load balancing when you start to want to do something a bit more complex. Now, with the application gateway, what it does, and it does it very differently than the networking load balancer that we just talked about, is the application gateway takes the connection from the end user, actually terminates that connection and creates another one to the backend pool. This actually does unlock a lot of scenarios for us. It allows us to do things like rewriting the URL or changing headers on that journey through our network. So again, lots of scenarios here that this application gateway can actually unlock for you. And it can also support the termination of SSL, termination, TLS, and certification management. So if you've got certificate chains happening within the travel or the journey of your application, then you can use the application gateway to try and manage that in conjunction with the Azure Key Vault, because the application gateway is obviously an Azure service and the Azure Key Vault is an Azure service, and there's native integration for those two applications or two services within Azure. Now, if we're thinking about the OSI model, the application gateway is a layer 7 load balancer, and it can support things at the back end such as virtual machine scale sets, Kubernetes clusters, public IP addresses, and even resources that don't live on Azure. So again, it can be used for potentially migrations, or if you're in the process of doing a hybrid configuration, some of your resources are sitting in Azure, and some of your resources are still sitting on your on-prem data center, waiting to be moved as well. Now, one of the features that I really love about the application gateway is called connection draining. So if you need to do maintenance on one of your backend, or if you want to actually change something or even remove it from the backend pool, what you can start to do is drain connections from that backend so that people are stopping hitting that backend option. And then once there's no traffic going to it, you can actually remove it without anybody having any issues. The last thing, again, any of us want is to take a backend pool member out of the network and people are hitting it. The application gateway is still routing traffic to it and causing some issues. You don't want to get anybody hitting a 404 error as such. So that's one of the features that I really love about the application gateway. Now, similar to what we saw with the Azure Load Balancer, we have different components that make up the application gateway. This again can be a kind of public or a private front availability. So again, you can have this public facing or you can have it internal. We do call the health probe something different when we talk about the application gateway. So it's called a listener, but it does the exact same job as the health probe. It just looks at whether your endpoint is healthy or not and can receive traffic. So that's something to be aware of as well. Now, like I said, the application gateway allows us to do lots of different routing options. And one of the scenarios here that you can see on this diagram is that if you want your traffic for images, so if you're hosting a lot of images on your website, it can go to one backend pool. And then if there's a query on your website for video files, it can go off to another backend pool. That's just a simple example of the routing that can be done, but it shows you the power that the application gateway actually have. Now, another feature that we have within the application gateway is auto scaling. And again, this is another great feature that application gateway offers you. When you're setting up your application gateway, you can configure a minimum and maximum number of instances of your application gateway. And as traffic flows into your application gateway, and if there's a spike somehow, what the application gateway will do is auto scale up to that maximum amount of instances. Then when the traffic actually subsides and there's less traffic going, it will go back down to the appropriate level, whether that be the minimum or somewhere in the middle. Now, this is great from an operations point of view because it means that you're not having to sit there and maybe watch it or wait for all the phone calls or, the complaints on Twitter coming through saying that the application or your website isn't scaling. Application Gateway can help you do that automatically. So again, that's a great feature and it stops the guessing game, because how many times have we over-provisioned a workload and had to pay extra money for it? This kind of takes that guessing out of it. And allows you to concentrate on other things rather than the operations point of view. Now, security is obviously a massive, important thing for every organisation, regardless of scale and regardless of how many customers you face. We have the Azure Web Application Firewall that can actually sit in front of or beside your application gateway and help detect or prevent attacks within your site. So the Web Application Firewall, or the WAF, can be configured with the OWASP rules, bot rules, or you can configure your own. And because it's a global resource, it can actually be applied to multiple examples. So here in this diagram, you'll see that we've got a WAF in front of our application gateway and also our front door, which we'll be talking about in a minute. But that means that if you have one WAF policy, you can actually ensure that you apply the same policy to both points, and then you have a consistent protection. And you've not got two policies hoping that whoever configured them actually read the right documentation, ticked the right boxes, and they're consistent. You can actually use that one policy across the two resources. So that's something to bear in mind about. Now, the WAF policy doesn't have to be applied globally or at the whole of your application gateway. It can actually be configured granularly as well. So you might have to have a different WAF policy if you want one at the top level and then one further down the chain, again, protecting something else that's happening along that journey. Now, I don't want to talk a lot about Kubernetes, but I do want to mention the feature that we have with Application Gateway in terms of AKS and the ingress controller. So the Application Gateway ingress controller will live as a pod within your Kubernetes cluster. And this saves a little bit of configuration because traditionally your ingress controller would be sitting behind a load balancer. So you're actually taking out a hop within that journey for your Kubernetes cluster here. And the team have actually been working on making this deployable really quickly if you are using AKS. So you can have now a one-line command deployment of not only your cluster, the add-on for the ingress controller and the application gateway. So instead of having to deploy 3 resources, there's now one command line that you hit and your deployment's done. So that's a feature to look into if you're looking at AKS and Kubernetes and clusters and stuff like that as well. Now, the third item that I want to talk about is Traffic Manager. Now, Traffic Manager is our DNS load balancer, and that allows you have a public-facing endpoint, and you can do various different routings with this. As you can see, we have 5 or 6 different routing types here as well, and we'll be talking about them in more detail. What the Traffic Manager actually does is takes the request, if it went to something like www.contoso.com, redirect it via a CNAME to the Traffic Manager configuration. And then depending on how you have your Traffic Manager set up, it would then disperse the traffic. And again, it can be Azure traffic or it could be something that doesn't live on Azure. So again, another great feature here if you're potentially running a hybrid environment between the cloud and your on-prem environment, or potentially if you've got resources in other cloud providers as well. So again, great features here and great functionality. This slide I've included because I actually think it's quite good in understanding how the traffic flows. What I'll be doing at the end of this presentation is actually sharing a link where you can download my presentation. So if you want to look at this in a bit more detail, then you can do. But basically what Traffic Manager helps your customer or your query do is actually start that conversation with the backend point. The query will come into the Traffic Manager. Traffic Manager will figure out the endpoint or the backend pool that's the best response for your end user who's made the request. And then the connection will actually start between your end user and that endpoint. It won't be going all the way through Traffic Manager. Now, one of the scenarios that I mentioned in terms of routing that we have is weighted traffic routing. So you can actually set it up so that you can depend on where your traffic is going. In this example on screen, we've got 50% of our traffic going to the East US instance, and then with our West US instances, we've got it split over a 1% and then a 49%. Now, you could be doing this because you're trying to take the traffic away from the West US, you're trying to drain that connection and you're trying to take it out to do some maintenance, or you might actually be doing some kind of A/B testing where you want to see how users perform to a different color theme or new logos on your website and see if they notice that kind of thing. So that's a scenario and an option for you as well. Performance traffic routing is all about trying to give the end user the best endpoint experience. So it'll try and route the traffic to the endpoint that has potentially the best latency or the slowest latency within that table. And this again can help improve the performance for your end users depending on the endpoints that you have. Now, geo-routing can be around how or where your users are actually based. So Traffic Manager will query where the request is coming from, whether that IP address is based somewhere in Scotland, and if it can try and route you to an endpoint that's closest to, say, Scotland. Or if you're in Australia, it'll try and route you to one that is closest to you. And you can start to get really granular with this. I'll be showing you a demo of this later on, but you can start to really get down into, the state. If you think about America or Canada, you can get down to the state, or you can get down to the province level and start to really dial down how you want Traffic Manager to route your endpoint traffic. Now, as I said, your endpoints with Traffic Manager do not have to all be based in Azure. They can be on-premise environments. And again, for that migration scenario, if you're in the process of moving your workloads into Azure, but you still have some that are on-prem, then you can have that as an endpoint as well. And again, this can be seamless for that migration, so that your traffic or your end users do not see the fact that you're trying to decommission something on-prem. You might be decommissioning a server that was really old, a 2003 server or something, and you don't want people to see that. You don't want to have an outage. So you have endpoints where they are in the cloud and people are starting to route to that as well. Now, nested profiles is something that you can have where you can start again to be really granular about how you want your traffic to be routed. And it can be quite complex from a management overhead to do nested profiles. But again, for those complex deployments where you're starting to think about different things within your environment, you can actually do that. It is supported to point a traffic manager to another traffic manager to another traffic manager and then to an endpoint. Now, two features that I love within Traffic Manager and have been playing with over the last few days are features called Real User Performance. Now, what this does is Traffic Manager will give you a slice of code, a slice of JavaScript code that you embed into your website. Now, every time someone actually hits that website, the JavaScript will kick off a chain of reactions in the background. So it will start to look at all the endpoints that Traffic Manager has available to it. It will start to collect data from those endpoints and see which one's the fastest. And it will report that back into Traffic Manager. And then over time, this will lead to Traffic Manager actually building up a much better network latency table or routing table for it to actually understand where your customers are coming from and build that, make it much better for your users. Now, another feature I love, and I actually only just got it working this morning, so I'll be definitely sure to show you that, is the traffic view feature. And again, this will show you where your endpoint users are coming from and where they're actually being routed, depending on the algorithm that you've set up. This can help you make informed decisions. So when we'll see the demo, we'll be able to see where people are coming to, where the cluster of people are. Most of our customers or most of the demo people that hit my website are based in the US. And we'll see that there's maybe no one in the Australia, so I could maybe do away with that endpoint. Rather than me talking to slides, let's actually dive into the demo. So let me pull up my Azure Portal. So hopefully you can see the Azure Portal here, and let me full screen this so as you get the best view. I've been playing with a lot of this technology and I have set up the Traffic Manager one. So let's have a look at the resources within Traffic Manager. So here we can see I have a bunch of web app services and I also have a couple of traffic managers set up. So if we go into my first traffic manager, it's fairly easy and fairly straightforward to set this up. We can see here that I have this traffic manager set up for performance-based routing. And I have a bunch of endpoints. I have one in the UK, I have one in the US, and I have one in Australia for that endpoint. Now, if we go over to the left-hand side and I'll show you traffic view, because this is the bit that I've been trying to get working for a few days, we can actually start to see the map of where people have been hitting that website from. Now, I'm not sure if you can see it, but the big blue dots on the map are actually my endpoints. So I've got the one in the US, the one in the UK, and one in Australia. If I click on this endpoint, it actually shows me where all the people that hit it actually were served from. So someone in Australia was actually routed to the US endpoint, and we've got some latency data here. So we've got that there was one where it's red and it's really slow. I suspect that might have been the Australia one. And we've got ones where it's really fast. This is just a demo environment and I've only got a few points of reference to show you, but you can start to get a picture of how this can actually help you when you actually look at a production environment. I haven't had a lot of people hitting it from Australia. I think I've got 7 people hitting it, so potentially that is something that I could do away with. That endpoint maybe is one that I could scale back, save myself some money. Or potentially it's an area of growth for your company. You know, you're maybe not making the best of, your office there or your retail options there. So you might want to actually start to do something with it. It's giving you data that you can actually make informed decisions about. You're not guessing and you can start to understand what's really happening. Now, if we hide the heat map, we can start to see some of these points of reference that this graph is actually drawn for us. We can see the endpoints that have been hit. We can see the IP addresses, the volume of traffic. We've actually got the latency information that the real user measurement has captured for us. So again, informed data about how we set up our traffic manager and potentially how we set up our application overall, and maybe our business strategy as well. Now, like I said, there's the option to do geo-routing, and that's slightly different when you set it up. So let me go into my traffic manager that's set up for geo. If I go into endpoints, again, we'll see we've got the same endpoints configured. But what I want to show you is the granularity that you can do with this geo profile. If we go to add another endpoint, we're picking an Azure endpoint, and I'm going to do test, if I can spell test. Pick an app service, and I'm just going to pick an app service that I have in the UK. If we go about thinking about geo-routing, we can look at the regional grouping. So we can say North America. If we look at this, we want to pick something, say, within United States. And you see here I've actually got the option for state, and I can go down to this state and I can say all the traffic from Washington, I want to direct it to this endpoint. It's maybe not a great scenario that I'm redirecting all the traffic from Washington all the way back to the UK, but you can see that scenario. You know, it's great for maybe, again, A/B testing if you want to test with a certain subset of users. If you maybe have a promotion running and you want to send people to that promotion that's only for people based in Washington state. But there's lots of play around all of this, and you can really get some powerful setups with it as well. One thing to be watchful of, and one thing I failed to when I was doing my demo, is I forgot that when a web app, you set up a web app, there are only certain tiers that support Traffic Manager. So it has to be one of the production tiers. So I think all of my web apps are running on the S1 tier, which supports Traffic Manager. Be mindful of that. If you're setting up a demo, some of the basic or the shared web app services don't support Traffic Manager, so you wouldn't actually get a response from them. So that's something to bear in mind and something I learned building this demo this week. Now, if we go back to the slides, I want to touch on the fourth load balancer service that we have, and that's the Azure Frontdoor service. Now, this is very different, and again, this is the one I think a lot of people get confused about when to implement and what's the option and what's the real benefit of it here. This Frontdoor offers you the chance to access lots of points of presence around the world, and try and give someone the best experience that's closest to them. So as we saw with Traffic Manager, we were routing some people from the US to the Australian endpoint, and we're sending them to the UK endpoint. And although Traffic Manager is a global service, it was taking some of that traffic and then pushing the traffic to the back end. So performance might have been fast on the initial connection with Traffic Manager, but then was really slow if that endpoint was the other side of the world. What Azure Frontdoor does is actually gives that connection to the end user at the point of presence. The point of presence actually does all the connectivity, does the caching, does the transfer, does the SSL traffic as well. So there's a lot more that you can do with Azure Frontdoor here. Now, Azure Frontdoor is a layer 7 load balancer if we look at the OSI model, but it's solely internet facing. You can't have an internal or a private load balancer here. You can't have a private front door. It has to be public facing. Now, as I said, Azure Frontdoor has lots of point of presence, which means it actually has a lot of failover technologies or capabilities actually built in. So this slide kind of demonstrates that. If your end user puts in the request to your site, it will pick the closest point of presence in the internet. The health probes at the back end, or the listeners that we're looking at our endpoints, will actually then find the most available endpoint and send it to that pool for us, so servicing that request for the end user. If something happened to that back end pool, the point of presence would route to the next available back end pool for our end users. If the point of presence went down, Frontdoor would actually start to look at automatic failover and point us to the next point of presence as well. So the failover capabilities are all built in there. You don't have to do that scenario-based routing. You can just set up Frontdoor and kind of let Azure do some of this for you. Now, again, this is a great one for migrations. So if you have resources on your on-premise environment in your own data center and you're starting to migrate to the cloud, again, you can start to have those endpoints being pointed from Frontdoor to the on-prem environment. And again, try and stop people from actually seeing you do that migration and have any outages within it. It's also there for if you want to provide services across multiple clouds. So if your strategy is to have multi-clouds in your environment and try and look at putting your workloads across different clouds, then Azure Frontdoor can help you do that, can help you be that layer so that, again, you don't have to necessarily do some of that routing and bake in some of that failover. Now, what I want to show you is a demo of this because I think it's most powerful if we go to a demo. So let's go back into the Azure portal. So if we go back to our Frontdoor. So here I have my Frontdoor configuration, and you can see it's a global resource, so it's set up with a region as such. The Frontdoor has one backend pool and one routing rule here for me. If we go into our Frontdoor designer, we can start to see how this is all configured. We have our front end, which hits techielasdemo.azurefd.net, which is a mouthful and a half. We then have a backend pool, which has all of our endpoint resources, and then we have that routing rule. If we have a look at what this is configured to do, we can see some of the settings once it loads up. I've went with a kind of weighted resource kind of routing rule here. You can see I've got 3 endpoints and I've given them all a high priority and then weighted them to 33 or 34% to get the maths right. So it's basically a round robin that will be happening with this Frontdoor. So again, this might not be the best scenario for my end users, but this is the configuration that I'm going with to see how it performs, and then I can change things as we go. If we look further down at some of the configurations, we can have the health probe set up here. We can have a lot of configuration around all of that, the interval that it will be testing our health probes for. We've got the load balancing, so it's looking at the sample sizes, it's looking at how many successful samples it needs before it takes something out the back end pool. So if we actually look at this in play, I want to show you how, if I grab the right URL, 2 seconds. If we grab my URL that I've got given, there is a website called GeoPicker that actually allows you to see what's happening across your sites for different endpoints. So if I was to do it right now, if I hit this in the UK, I'd be routed to the UK. So I want to use this to test what's happening elsewhere. And we can start to see that it's testing these various locations across the globe, and it's starting to actually pull back the request. You can see the reaction times here for a lot of our resources. There's 2 milliseconds, there's 1 millisecond, and we've got 19 as the lowest or the highest. Virginia doesn't seem to be working at all, but I was testing this before I came on screen with you guys and girls, and Virginia was not working, so I suspect that something in the background with GeoPicker is not actually working here. I'm not sure if you can quite see this, but each of my endpoints are based in different locations, so I've got a different website that will show what's happening. You can see the Brazil one here is actually hitting the US one. My Singapore test here is actually going all the way back to the UK because it's deemed it's the fastest one. California hits the US, Ireland hits UK, and Australia actually hits US as well, even though there's Australian endpoint there. So it's routing it just depending on that round robin traffic and what's happening there as well. So it can give you some information, and you can see that it's fairly fast across the board if we ignore Virginia. The milliseconds and the latency there is actually quite quick and quite responsive for our end users. If we go back into the Azure portal, I want to show you this web application firewall. I've got a policy set up that's protecting my web application firewall. And if we go into the configuration, we can see that I've got a prevention rule set up. If we go into the policy settings here, I've got prevention set up, so it would actually stop detection. So if it detected something malicious happening to my front end or my front door, then it would actually stop that. We do have the option to do detection, which is a great option if you are worried about false positives, or you're testing something, or you want to understand what's happening. What it'll do is it'll detect that threat, but it won't actually stop the threat. So potentially the threat could get through your network. So you would have to have the right monitoring set in play so that would do that. But again, it's great if you're trying to understand if there's any false positives happening within your environment. Now, there's tons of rules that you can use. I just turned on all the rules depending on what I wanted. I just went with everything. And you can see if we scroll down, we've got tons of theirs. We've got the kind of normal attacks that you might expect. So PHP injections. I think if we scroll down, we'll have SQL injection attacks. My website doesn't have any of that. It's just a demo, but you can see that there's lots of rules there. So you don't have to go out there and think about all these rules and think ahead about how an attacker is going to potentially attack your website. Now, if we go back to our slides, the question I posed at the start is, how do you choose which one? When do you think about which one? And is it a versus case, or is it a case of a combination of these resources? What I would say is, when you are looking at your load balancing and thinking about it, think about things like latency sensitivity, what type of workload you're actually using. Like I said, your load balancer at the very start, we talked about how it can have endpools with virtual machine scale sets or IP addresses, whereas some of the other ones can support things like your Azure Kubernetes cluster services. So again, think about the workloads that you're going to be using. Think about whether you're using a hybrid connectivity model. So if you have resources in Azure and outside of Azure, again, you need to think about that so that you pick the right choice. Now, a service that we launched within the Azure Portal is actually helping you understand some of that. So you can search in the Azure Portal for something called Load Balancer and Help Me Choose. And then it will show you a small site that actually walks you through some questions. It'll ask you things like, is your workload deployed to multiple regions? Is it split in that hybrid connectivity? And it'll give you some recommendations based on your answers to those questions. So it'll give you some guidance about what you're thinking, or even confirm that you are going down the right track. That site also has information around educating yourself further about the choices that it's recommended. So there's lots of information to the documentation, information to learn modules, or videos talking about these features as well. So well worth having a look within the Azure Portal at that service and seeing if it can help you. Now, the one thing I want to talk about, and going beyond that load balancing and thinking about some of the other services that we saw in that fourth quadrant right at the very start of my presentation, and that's the Azure CDN service. So this can also be used to help with the performance and the load of your web application. Now, there's lots of things around the CDN, but basically it helps to take those static images and potentially even dynamic images, or video files, depending on the configuration of your CDN, and speed up that reaction for you. I've got a colleague who has a static web application sitting in Azure, and it's based all here in the UK on a storage account within the UK region. But he fronts that with Azure CDN, and he gets really great performance times, and it saves lots of money for him as well, because the CDN is caching that and there's not pulling back of that data out of his storage account, and he can service people who are sitting outside of the UK. So again, using the points of presence within the Azure networking, it can actually help you provide faster performance, because let's face it, nobody has any time for slow websites nowadays. It's really easy to set up with the Azure CDN. It can be a few clicks away from setting it up. We have native integration with a lot of our Azure services. For example, when you look at an Azure storage account, and if you're taking advantage of the static web application, there is a little box where you can start to actually deploy your Azure CDN without even leaving the Azure storage account. So lots of information there, and fairly cheap to run as well. Now, the other thing that I want to talk about, and it wasn't on my slide at the very start of this presentation, is actually our managed databases. And I want to focus on the Azure Cache for Redis service that we have. And this is something that you might want to have a look at within your environment if you have an element of database within your web application as well. Now, it's based on that open source project, Redis for Cache, which is not absolutely easy to say. I always get tongue-tied here. But it allows you to start to look at some of your data structures, start to take some of the load off your database. So rather than having a beefy or a chunky database solution servicing all your traffic, you can start to use Azure Cache for Redis at the front of that to service some of those requests. And again, a bit like the Azure CDN, caching some of that traffic. So again, your resource at the back end, your database does not have to be large. Now, this is a managed service on Azure, so we take care of the patching, the updating, the provisioning, the scaling of it as well. So you can look at this as a cost-saving measure for your operations point of view as well within your environment. And because it's integrated with, again, a lot of Azure services, it supports Cosmos DB, App Service, MySQL, Azure SQL, or PostgreSQL. So depending on what you want to use for your database, then there is support there for you. And because it's an enterprise-grade service, or something that we call an enterprise-grade service here at Microsoft, you can take advantage of that 99.999% availability across the board. So again, highly available, and again, adding some performance action to your workload and your application. Now, I've talked tons, and I want to just show you some example architecture where you could potentially use the solutions that I've talked about. So here we have a basic web application with a front end that's supported on an Azure web app, and then we have the back end with it, which lives on an Azure database for MySQL. We've got Azure CDN, which helps with that dynamic content. And we've got the Redis for Cache instance that again helps take some of the load off our database. And we've also got application insights in here where it helps gather some of the monitoring around your web app, some of the performance issues, detecting any issues, and gives you a great insight into what's happening. But there's an example of how you can use CDN and Redis Cache together. Now, if we get slightly more complex here, we can start to combine a lot of the features that I talked about. So we've got Azure Frontdoor, we've got Azure CDN, we've got Redis for Cache, we've got Azure Search, we've got Cosmos DB there. It isn't an either or in this scenario. They're being used together to make that the best solution, the best architecture for our end users and our customers. Now, if we talk about Umbraco, and I found this reference architecture within our library of architecture here, and this is maybe a simple solution, but it gives you an idea of, again, how you could potentially configure your Umbraco solution. You've got your front end, you've got a separate web app for the admin side of it. You've then got a database, a SQL database, and you've got Redis for Cache there as well, again, helping with that performance and caching some of that session state data and output cache. Again, we have a storage account for the media and for some log files, and we've got application insights here as well, gathering some data about our web apps. This is just an example, and there's obviously only using the Redis Cache solution there, but potentially you could put Azure CDN there, you could put the application gateway, you could put Frontdoor in front of it. The possibilities are endless, and this is just an example to give you a little flavour of how you can combine some of those services. Now, thank you so much for having me today. As I said, I've talked a ton about a variety of different services and shared a lot of information and some lots of slides with lots of detail in them. You can go to this URL on site, on screen at the moment, and grab a copy of the slide deck, or you can see a bunch of resources and a bunch of further learning resources that can help you try and understand how to scale with Azure. I thank you so much for having me today. I'm not sure if there are any questions. Hopefully Emma will be able to pop back and say hello.
Hi, Sarah. Hello.
Hiya.
Thank you so much for that. And thank you for talking a ton. It was a wonderful, wonderful presentation. I learned absolutely loads. I thought, so there was an awful lot I didn't know about. Okay. Connection draining, I thought was incredibly interesting because it just gives your ops team some confidence when they're doing their maintenance and things like that. It was a real kind of it's an incentive to work with it, to work with Application Gateway, because you know that you can, you're not going to suffer from any downtime.
Also helps trying to plan your maintenance during hours, potentially, rather than doing it at 2 a.m. when there's no traffic. You could potentially schedule it during the day and avoid all those late nights and overtime costs. So yeah, I like to highlight those features because no one wants to be doing out of hours work anytime.
No, it's an easy sell for an ops team, isn't it? Let's do it during daylight hours. It would be fab. The traffic manager real user performance was fascinating because it builds the data back in as it learns the data, right? So you're never going to be, latency is going to become less and less of an issue, just each time, the more it learns from the real user experience.
It's pretty insightful, and from the demo I showed, I didn't have a lot of obviously traffic going through my demo website, but you can see that it was starting to gather that data, and hopefully over time, the longer that I ran that, you would get the traffic would be much more attuned to where your end users are. I just love those features in Traffic Manager, to be honest, Emma, because it gives you that insight into, as an ops person, I've had those conversations where I've said, we don't need so many servers, or we don't need so many web apps. Can we turn them off? And people have said, no, it's going to affect performance. But those kind of screens help you build that use case and potentially even build that use case for scaling up the way. It's not always about taking away. I think but yeah, it's a great feature from there. It's giving you lots of information and lots of data to build those use cases, whether that be for scaling up or scaling down, or potentially, like I said, even thinking about the business, how you address, the fact that, my web app didn't have a lot of traffic from Australia. That could be a growth market for your, a potential retail customer. There's lots of information that you can pull out from this technology if you know where to look and know what to implement.
Yeah, it's really interesting because it doesn't just make your ops teams happy; it helps your marketing teams. It's fantastic. We little traffic from Australia. We need to do more. It's wonderful. And the front door protection, when you were going through the list of rules, all already there. It was just, for a security phobe, it just looked fantastic, really easy to implement.
Yep, absolutely. It's kind of almost, wasn't quite a one-click deployment, Emma, but it's in that vein of you can set it up and you can answer all those questions that your security team can go and be like, nope, set that up. I've met that requirement. Let me go to production with this type thing. And you can obviously build on that. You can build on your own custom rules. And as things grow, then I'm sure we'll add to all those rules as well. I enabled all those rules. I don't think I talked about this during the demo. I just went with a blanket all, but you could pick ones that you don't want happening, the ones that are false positives in your environment, and start to really configure it down to what you need. I just turned on everything because I thought, why not?
Wonderful. No, actually, we do have a question around that. So you went for blanket enable all. So when new rules need to go in, is it the user's job to go in and add those, or if you have a blanket rule, will newly added rules, will they also be in there? Or so what level of engagement does the user need to have with adding new rules?
It will kind of depend on what configuration you've went for. If you've went for the managed rules one, then as new rules, maybe new standards from the OWASP team comes into play, they should just get added automatically. Obviously, I would say keep up to date with what's happening and make sure they are actually getting added in. With these things, it might take a few days for changes to happen, and you might potentially not want to wait a few days, so you might have to do it manually yourself. So there is an element of it's a managed service, but please don't just let it run away on its own as such, and make sure you're being vigilant and keeping up to date so as that you're not assuming that Microsoft are doing something and they potentially haven't done, because it takes a few days for things to happen. Sure. If that makes sense, Emma.
Of course, yeah, absolutely it does. And then the other question we have is, how do we manage if we want to migrate from one version to another? So I guess from load balancing to traffic manager or any of the other switches. Is it an easy switch?
it will just be like a migration project, a bit like how I was saying, if you're migrating from on-prem up into the cloud. If you're migrating your endpoints from, say, a load balancer to traffic manager, you could potentially have the two running and then just start to move the connections over, start to see the traffic. You can't flip a switch and say, I'm now wanting a traffic manager and convert your load balancer into a traffic manager. So you would have to run them side by side and start to move your endpoints and start to move your traffic across slowly that way, Emma. So it isn't just you don't just click a box and it kind of upgrades or changes it. It's a migration project.
Lovely. Well, Sarah, that's all the questions that we have, probably because you were incredibly thorough. It was a really fast talk, and I'm really looking forward to seeing the slides. But thank you so much for joining us today. That was really wonderful. So I'm going to say goodbye to you for now and welcome Arnold back. Thanks, Sarah.
Cheers.
Hey, Arnold.
Wow, it was hi. Wow, that's really interesting, and I think I also learned a lot. But I'm also not sure if I really understood everything just yet. So I maybe have to rewatch the session to get up to speed with everything that Sarah told us. Might be a good idea to load balance worldwide to the DUG website. Now we have all this international traffic coming in this month.
We might need it now.
Yeah, so thanks, Sarah, for this great session. And also thanks, Emma, for hosting this Q&A again for us. Right after this session, we have Azure Snacks Cafe on Microsoft Teams, and you can find the link in the chat, but also on the virtual.duke.nl website. So join in. It's not recorded. You can speak freely. You can ask questions on or off camera or in the chat, whatever you like. It's just a get together as you would have after a normal meetup, informal. So please join in. We would like to see you there. Next week, there's another Azure Snack, and it will be about containers in Azure. So it's also really interesting, and certainly with Umbraco version 9 will be launched at the end of this year on .NET Core, .NET 5. It will be much easier to do containers. And with the beta of V9 coming up next week, it's a great time to start playing with containers and stuff like that. So really looking forward to that session as well. And finally, don't forget about the Azure Challenge. So you can win an Azure Badger, and I know that a lot of people want those toy Azure Badgers. And again, you can find the link on the virtual.duke.nl website. So yeah, we hope to see you all in the Azure Snacks Cafe, and otherwise hope to see you next week. And stay safe.